Today we're going to shift our focus to one of the most important ideas in early childhood mathematics, place value in base 10. Up to this point in the course, we've been building a foundation for how we think about math learning, how we plan instruction, and how we make decisions in the classroom. This module builds directly on that work by giving us time to slow down and really examine place value through a developmental lens. Place value is not just another topic in the standards. It is the structure that makes our entire number system work. When students do not have a strong place value foundation, we often see them relying on memorized steps that stop working as numbers get larger or situations change. This is also why place value shows up so often when teachers are analyzing student work. Many of the errors we see in multi-digit computation are actually place value misunderstandings underneath. So even if you've taught place value before, revisiting it in this way helps strengthen instructional decisions across grade levels. In early childhood classrooms, place value develops gradually. Students do not start by thinking in tens and ones. They begin by counting objects, coordinating number words with quantities, and noticing patterns in the counting sequence. Over time, they learn to group objects and eventually they learn to unitize, to see 10 ones as a new unit called a 10. This progression from counting, to grouping to composing and decomposing units takes time. It rarely happens in a single lesson, or even a single year. This is why the models and methods we use to teach place value matter so much. Tools like 10 frames, linking cubes, base 10 blocks, number lines, and place value charts are not extras. They are essential representations that help students see the structure of the base 10 system. Effective instruction intentionally moves from concrete experiences to visual representations and eventually to abstract symbols. Skipping or rushing this progression often leads to fragile understanding. To picture what this looks like in a classroom, imagine students working with the number 34. Rather than starting with the written numeral, students might begin by building 34 with linking cubes. Some students may create 3 groups of 10 and 4 ones. Others may count out 34 individual cubes. Both approaches are meaningful because they show us how students are thinking. At this point, a teacher's role is not to tell students which approach is correct. Instead, the teacher might ask, "What do you notice about how your cubes are organized?" Or, "How could you make this easier to count?" These questions help students move toward grouping and structure, while also giving the teacher valuable information about student understanding. Designing and facilitating moments like this begins with thoughtful planning. In this module, you'll examine a place value unit from high-quality instructional materials and align it to the understanding by design framework. Backwards design helps us step back and ask 3 essential questions. What do we want students to understand about place value? What will count as evidence of that understanding? And what learning experiences will support students in getting there? Many high-quality math curricula are already built using backward design. That means planning does not start from a blank page. Instead, it involves studying the unit carefully to understand the central mathematical ideas, how lessons are sequenced, and how representations evolve over time. For example, a unit may begin with counting and grouping objects, move into drawings and place value charts, and eventually connect those ideas to written numbers and equations. Seeing this progression helps teachers maintain coherence across lessons. Assessment is a critical part of this work. In mathematics, assessment is not just about checking answers. Informal assessment happens when teachers listen to student explanations, observe how students use models, and analyze student work. Formal assessments help identify patterns across the class. Together, these sources of information help teachers decide what to emphasize, what to revisit, and how to adjust instruction. For example, if a student represents 34 as 3 ones and 4 tens, that response tells us something specific about how the student is interpreting digits and units. Rather than correcting the student right away, a teacher might ask, Can you show me where the 30 is in your model? Or how many cubes are in one of your tens? These questions help pinpoint whether the issue is counting, grouping, or place value language. Now let's connect these ideas to classroom practice through a case study lens. In a pre-K classroom, consider a student who can recite numbers but struggles to count objects accurately. During a center activity, the student assigns more than one number word to the same object. This tells us that one-to-one correspondence is still developing. Instructional support might include slow, intentional counting routines, physically touching each object while counting aloud, and matching number cards to small collections. These experiences build early number sense, which later supports place value understanding. In kindergarten, consider a student who can count by ones, but becomes confused when crossing decade boundaries, such as moving from 29 to 30. This suggests the student does not yet see 10 as a composed unit. Instructional support might include bundling objects into groups of 10, using a hundreds chart to highlight patterns, and counting collections by organizing objects into tens and leftover ones. These experiences help students connect the counting sequence to the structure of the base 10 system. In first grade, consider a student who can read multi-digit numbers, but struggles to explain what each digit represents. When shown a number like 132, the student can read it but cannot model it using blocks or drawings. Support might include building numbers with base 10 blocks, using place value mats, and asking the student to describe how many hundreds, tens, and ones they see. This strengthens the connection between symbols and quantity. In second grade, consider a student who writes numbers correctly but struggles to decompose numbers flexibly. The student may rely on a single expanded form, and have difficulty representing the same number using regrouped tens and ones. Instructional support might include tasks that ask students to represent numbers in multiple ways, use base 10 blocks to regroup, and connect those representations to equations. This kind of work supports deeper place value understanding and prepares students for later operations. Across all of these examples, the central idea is the same. Student errors are not mistakes to fix quickly. They are information about how students are thinking. When teachers understand place value development and intentionally use models, questioning, assessment, and planning, they are better positioned to respond in ways that move learning forward. Revisiting place value in this way strengthens instruction at every level. It supports clearer planning, more responsive teaching, and classrooms where students develop meaningful number sense grounded in the structure of the base 10 system.